look at this integral. We have tan inverse x as well as log of 1 minus x upon 1 plus x. So here we'll be using effectively trigonometric identities. So one of identities is, remember, we have tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. This I will be using effectively over here. As well as, remember, we have tan inverse of 1 is same as pi by 4. So at tan pi by 4, its value is 1. If I substitute u equals to 1 minus x upon 1 plus x, let's see how. So if I substitute u equals to 1 minus x upon 1 plus x, then now can I write like this? X equals to here 1 minus u upon 1 plus u, because u and x are inverse itself, okay, is interrelated each other and one is inverse of other. Therefore, from here I can find dx. From here I can find dx. Dx is differentiation is u upon v rule. Over here we have 1 plus u raised to square and then 1 plus u. Differentiation of this is what? We have constant is 0. Here we have minus 1 minus 1 minus u, and then differentiation of this is here we have 1 is equals to 1 plus u. So if I send minus inside, I will get minus 1 minus u. Here I will get minus 1 plus u. This gets cancelled. 1 plus u raised to 2. Here minus 2 upon 1 plus u raised to square into dx. So I will getting dx as this. So I can send, this is what? This is my dx. This is my du. So dx whole dx I can write like this. So let's send limit when x equals to 0, u tends to 1. Okay. What about x tends to, when x tends to 1? When x tends to 1 over here, so 1 minus 1 is 0. So 0 upon 2 is become 0. U tends to 0. Therefore, this integral becomes 0 to 1. Here 0 to 1 become 1 to 0. So 0 to 1 become 1 to 0. What about tan inverse? What is x? X become 1 minus u upon 1 plus u. 1 minus u upon 1 plus u into log of whole this become u, and then dx is what? My dx is over here. Here minus 2 upon 1 plus u raised to square du. So whole this we have. Now look at this. Okay. Now let's see this tan inverse 1 minus u upon 1 plus u. Let's see. We have tan inverse x plus tan inverse y equals to tan inverse here x plus y upon 1. If it is plus, then minus xy. Okay. So since minus is there, so what we can do is instead of y I will write minus y. So this become tan inverse x plus tan. So this become what? Tan inverse. Tan of minus theta is same as minus theta. So I can write minus of y is equals to tan inverse x minus y upon 1. This become plus. Okay, 1 plus xy. So I need 1 minus u upon 1 plus u. So instead of x I can write 1, and instead of y I can write u. Okay. Now in order to get this become tan inverse. What is x here? 1 minus tan inverse. Instead of y I have to write u is equals to tan inverse. So 1 minus u upon 1 plus u. So what is tan inverse 1? Tan inverse 1 is at 45 degree. So I can write pi by 4 minus tan inverse u is equals to tan inverse 1 minus u upon 1 plus u. So what I can do instead of this, okay, instead of this, I can write like this. Therefore, this is same as 1 to 0 pi by 4 minus tan inverse u into this minus 2 I am sending outside. So what I can do is this minus, I will interchange the limits. So instead of 0, 1 to 0, it become 0 to 1. This 2 is over here. This minus has gone. So what we have, log of u upon 1 plus u the whole square du. Now what we can do is this term, whole term I can send over here as well as over here. Okay. Therefore this is equals to twice 0 to 1. So let's distribute this. Here pi by 4. Okay. Here we have pi by 4 log of u upon 1 plus u raised to square into du. Okay, this 2 is outside, so I am sending inside also, minus 2 integral 0 to 1 tan inverse u into log of u upon 1 plus u raised to square du. This pi by 4 I can send outside, so I can write over here this is 2 pi by 4. So integral of this, integral of 0 to 1 log u upon 1 plus u square du is, we have 2 pi by 4 is minus log 2. Okay, how come log 2? You can, I will write in description the length of this integration. So I am using integration of this equals to this minus 2. Now what I will do here, I will apply integration by parts. Okay, now here this is first function, I will choose this is first function and this is second function. Okay, so here we have 2 tan inverse x as it is, tan inverse u as it is, integration of this is become minus log 2 I am using. Okay, and then minus integral differentiation of this is 1 upon 1 plus u square and integration of this is minus log of 2 into du. Limits from 0 to 1. So minus I am sending outside. Here I get 2. Here minus log 2 upon log 2 pi into log 2 upon 2 minus I am sending inside minus 2. So here minus minus plus 2 log 2 tan inverse u plus minus minus integral 1 upon 1 plus u square du is minus pi by 2 log 2 plus 2 log 2 tan inverse u minus log 2, this is same as tan inverse u, limits from 0 to 1. If I subtract these two, I will get only 1. Here twice is there. So if I take this, 2 minus 1 is 1. So I will write only this one. So from 0 to 1. Okay. This same as minus pi by 2 log 2. If I substitute upper limit, log 2 tan inverse 1. Okay. Tan inverse 1 is what? Pi by 4. Okay. Into pi by 4. Tan inverse 0 is. So therefore, from here I can take log 2 common. Log 2 if I took common, minus pi by 2 plus pi by 4. Okay, you can keep like this or you can simplify. Okay, this is the required answer.